I would get started, but I understand there's a green light that I'm supposed to be waiting for. The red has started to flash. Oh, all right. So straighten my tie here. Uh, we need to debug the code. The blink isn't really very consistent. Is it Morse code? Green. All right. Welcome. Welcome, everybody. My name's Dan Good. And if this works, yes, it does, then we're here to talk about Bash. Well, actually, I'm a fan. I am not here to bash Bash. If anything, I'm here to bash certain assumptions or presumptions about Bash. Lots of people tend to think that Bash and scripting in general is very error prone. Well, I'm getting ahead of myself. Okay, who am I? I'm Dan Good. I actually gave this talk in 2013, and I decided when I saw the call for presentations this time, and they were specifically asking for, I think Bash was mentioned, I'm like, I got a Bash talk. I could just update it, right? So this is my updated Bash talk, and surprisingly, I tell you one of the things I did when I updated the talk is I threw out some things I don't use anymore. What don't I use anymore? I don't use Perl anymore. You know, it's kind of sad, but I don't use Perl anymore. But what do I still use? I still use Bash. So that kind of says something. Little history. So Bash, of course, is part of the GNU project. It's written by Brian Fox. Interestingly, it's one of the very few things that the GNU project paid somebody to do. Most everything in GNU and free software in general is, volunteerism. But Stallman thought it was so important to have a born compatible shell that they actually hired Brian Fox to write it. And he did a great job. And it was released in 1989. And I've been using it almost that long. So it says something that Bash is still relevant today, given that, it dates all the way back to the 90s. So I put bulletproof in the title, and that's that's clickbait, right? What does bulletproof mean? So I've got some words here to say what I'm trying to communicate when I say bulletproof. I say robust, predictable, repeatable, and transparent. And every one of these words I think is important. Maybe the most important is transparent, because when you're writing code and when you're writing Bash scripts, you want to have a really strong understanding of what's actually happening. And that's how you manage to solve the problems when they occur. So we'll maybe touch on each of these as we go, or maybe this is the last time you'll hear any of these words. I don't know. I don't have a script. So let's keep going. What have we got next? Oh, yes. I don't mean secure. I'm just going to go out on a limb and say if security is critical, don't write it in Bash. Now, does that mean you shouldn't use Bash? No. You should use Bash everywhere you can. But if you're exposing it to a network port, if you're giving it to an untrusted user, don't use Bash. Don't write setuid bash scripts. There are too many attack vectors, and I've listed just a few here: path, LD library path, input field separator, temp file hijacking. And of course, there was the shell shock bug, the bash door bug. So that was bad. But that kind of that's the proof, that proves the point that was only dangerous if you had Bash operating in an environment that was exposed to a network or that had untrusted users. So if you limit those exposures, then Bash is perfectly good to use. So when you're automating your own things to run on your own box or your own server, Bash is a great way to do this. So let's get down to the nuts and bolts. Very practical advice, and I'm guessing some of this is not going to be new at all, right? Always set path, always use umask, because it's easier to use a umask than to remember to go back and chmod every file a script creates. And path, so long as it doesn't have any variables in it, is very predictable. So one of those words as part of Bulletproof was predictability. Having your path be specifically defined and short makes for a much more predictable outcome. Set-xv. So this is something that I use in all my bash scripts, and I recommend everyone use it in all their bash scripts, but not everybody seems to have even tried it. What does it do? Set-xv makes bash become much more verbose. Bash will write out each line as it is read, and then it will write out again that line after it has gone through the various steps of, what are the steps? Well, I'll just read it. Path substitution, word splitting, expansion. All of that stuff happens, and then it writes it back out. So that second line is going to have a plus in front of it. Now, maybe the thing that gives set-xv a bad rap is that sometimes it's kind of non-intuitive what you get back. And when are those times? Those times have to do with pipes, shell functions, and redirections. They can be non-intuitive. I've got some examples, and I'll kind of point it out as we go. It's like, yeah, that looks a little funny, but once you get used to that, it's really valuable, I think. So if you're going to have all this, okay, what's up? You know, I always use them as a unit. So one of them is responsible for the line that's echoing it as it's read, and the other one is responsible for echoing the parsed version of it. So I don't remember which is which, but I always use them together. Yeah. Great. We have an answer. V is when it's read, X is after it does all of its fancy stuff. And I apologize, I'm not repeating these questions for the people on the live stream. I'll try and be better, but people feel free to remind me and I'll try and be better. Thank you. Okay, so this is fundamental. If you're going to use set-xv, and you're going to use it when you're not sitting right in front of it, then you need to get that output and get it into a file so you can look at it later. And that's what this does. So we know that exec has the usual use of replacing the shell with some other program. But if you use it just with a redirection, it doesn't replace the shell. All it does is accomplish this redirection for the calling shell. So this is titled to greater than log file. And that means take the standard error and append it to a log file. So reiterate standard error captures the output. My typical usage. What is my typical usage? I usually use this little bit of syntax down here. 3 greater than amper2. That means take the standard error and duplicate it onto file descriptor number 3. And I do this so that I still have the original standard error that I can write to later if I want to. Then, greater than $me.log, this says take the standard output and append it to this log file. 2 greater than amper1, this says take the standard error and write it into the standard out. So, the end result is both standard out and standard error is going into a log file, and I still have a duplicate of the original standard error I can write to. So I find this a useful bit of boilerplate that I put into most every script I write. Let's keep going. Maybe I should poll the audience. How many people already do something exactly like this in all their scripts, or something pretty close? 3 or 4. Okay. So for some people, this is kind of new. So this is, yay, all right, good. Because, you know, I hate it when I give a presentation and I feel like I'm the stupidest person in the room, you know, that everybody else should be giving the talk instead of me. So if some people haven't seen this before, that's good, because maybe I can help. All right, ad hoc error checks. I only throw this in here to say this is what people usually do. They usually write lots of code around errors. And, you know, in most programming languages, you don't have a lot of choices. Writing error checking code is fundamental. Bash is one of the few languages where you kind of just say, tell me everything you do, and throw it in a log file, and I can sift through it later. So you don't have to write a lot of ad hoc error checks. And here I say a few reasons why they might be bad. Mostly because you never write the error check that you really needed. You always forget that one. And then later you figure out, oh, let's write another one. Click. There. Set-E. This is finally where the magic happens, really. This is how you can have what I call Bulletproof Bash scripts. What does set-E do? It adds an error check to every simple command. So Bash says, I'm going to pay attention to the return code of every command that's being run. And if that's a simple command, and there is an error, meaning a non-zero exit code from that program, then I am going to stop the script. Bail out. So, does that seem extreme? It's valuable. Now, it works for built-ins. So CD very clearly is, if you can't get to the directory where you want to go to do the thing you want to do, that's an error condition you want to catch. So set-E will catch that error condition for that CD. Now, why did I use that word simple? Simple is kind of the out that Bash gives you. Bash says, if you know this command can fail, or if you need to test, like with an if or a when, then I'm going to just let you pay attention to that result code and respond to it directly. But if it's simple, not part of an if statement, then that's when Bash steps up and does what it does. So, trap. How many people regularly use traps in their Bash scripts? 2. Okay. Okay, so let's talk about trap. Trap is great. Trap is an interrupt. Trap is something that happens in response to a condition. The simplest condition you can respond to is exit. Exit is when the script is exiting. This trap is run. Now usually there is nothing attached to this trap, so it does nothing. But the minute you say trap, bang, exit, whatever, for various values of bang, you're saying, Bash, I want you to run this code or this command when you exit, regardless of why you're exiting. So this is an important part of how you can make bulletproof Bash scripting, because very simply, if your shell script exits, and it exits because of an error, you want to be alerted to the fact that it exited because of an error. So my very typical usage for the exit trap is to write to standard error that the script failed. Give me some indication the script failed, so I know I need to go look at the log file and understand why it failed. And that is really simple but fundamental. Okay, and to disable a trap, you just say trap dash and then the trap name. And in this case, the chap name is exec. Set-u. So this is another nice one. This treats unset variables as fatal errors. You're going to get unexpected behavior if the variable should have a value and it doesn't. So this is really simple. It makes these variables become an error condition. Now, sometimes you really want something like $2 to be optional. And how do you accomplish that? Well, you can use the bash notation with the brackets around the variable name, :-. And that basically says, let this be optional. I missed something there. It said take care when used. Oh, right. This will come up in the example a little later, but you want to be careful about relying too hard on that in conditions like pipelines, and we'll see that in just a minute. Flock. So this actually relates to sort of the example I gave in the description of this talk when you're running something out of cron, out of your daily cron. And you come back a week later and you find that your cron job, which was supposed to just run and exit once a day, now has 30 or 40 copies, and you don't know why, and they're all still running. I see a nodding head. I'm glad someone can relate to that. That's something that's definitely happened to me a few times. So flock is a very nice way to get around this problem. What flock does is it takes a file and applies an exclusive advisory lock on that file. So what does exclusive mean? It's not shared. Only one can hold an exclusive lock at a time. What does advisory means? It means it's not enforced by any mechanism. The kernel isn't coming in and saying, oh no, everybody has to play nice. All the programs have to agree that the lock means the same thing to them. So that's what advisory means. Now, flock takes a switch in for non-blocking. If you don't use the in switch, it's going to wait. If it can't get the lock immediately, it will wait until it can get the lock. That might be what you want, but in my usual usage, I use the -in because I want that script to exit immediately if it can't get the lock. I want one script to do one thing at a time. And if I run two versions of that script at the same time for whatever reason, I want only one to win the lock and the other one not to do anything. We can use it on a file handle opened by bash, and that's nice. Usually you say flock and then a command, and it runs that command under the lock. But if you use it with a file handle number, then you can put that in your bash script, and the lock lasts while that file is open, which is basically going to be the lifetime of your script. And again, that lock is going to be automatically released when bash exits, because bash is going to let go of that file. Closing the file releases that lock. Okay, now this is an example script. I hope this is big enough. This isn't a terminal, this is a slide, so I don't really have a lot of options to make this bigger for us. But this is an example script which is intended to be very simple, but it is actually a script I wrote once upon a time, and I stripped out a little bit just to make it a little more pedagogical. So what do we have at the top? We have the export path, we have the umask. The next bit of boilerplate is just about getting a name for my log. I'm going to release these slides later on a website if anybody wants them. So the next bit of boilerplate just assigns a variable me to be the name of this script. Then there's that bit of exec to get me that standard error saved and to put standard out and standard error to the log file. Then there's my set xv and e and u. So all four of those letters are together on that one line. And then I just have date and host name. Why do I have date and host name? Because when you're going back and looking at a log, it actually helps to know when this ran. And sometimes if you're running this script on multiple boxes, it helps to know which box this log came from. And because we're using bash to write to this log file instead of some nice logging program that's going to put a date on every line, we do it here at the top, or at least I'm doing it here at the top. So here's bang. Bang is a shell function, and it does very simple thing. It says it failed, and it's writing that to that saved standard error, which is on file handle 3, and then it's exiting with 1. So a failure exit code. That's all that shell function does, and I'm using trap to attach that shell function to exit. Basically what I'm saying here is there is one successful path through this script, and I need to get all the way to the end of the script where I untrap exit for it to be considered a success. If that script exits at any other time, that's a failure. So this is another notion of how you make a script predictable and repeatable, is you have one way to succeed and infinite ways to fail, but just one way to succeed. So here, the way to succeed is to reach the end of the script where we detach the trap and exit with a 0 value. So what happens in the middle between trap bang exit and trap dash exit? What happens in the middle is we're changing to a directory, sourcing a config file. We're looking for any files that are older than a certain amount of time that match a certain name, and we're removing them. So this is a very simple throw away old files kind of script, which is kind of bread and butter of my old sysadmin days. This is a simple cleanup script. So let's say I run this script now. This is a contrived example, so I'm going to make it fail a lot of times to sort of show you what it looks like when you're looking at that log and it's failed. So right off the bat, failed. I run it, all it says is failed. And that's all I wanted. I wanted it to tell me it failed, so then I know to go look at the log. I didn't want to write long error messages, because that's all that ad hoc error handling that gets you in trouble, where you forget the important errors and only pay attention to the less important errors. So this failed. Why did it fail? So here I'm just catting the log. This log file is called opt-log rmlogs.log. And you can see the xv output here. So date, that first line just says date. That is the line from the script being echoed. The second line says plus date. That is after date has been interpreted. And it's the same as it was, which is fine. And then we get the date because we captured standard output to the log file. So I just redid these slides the other day, so it's going to be a recent date. And then the host name, this computer was called Jet. You see the shell function is being echoed, but it's not being run. So we don't get the plus line, it's just being echoed. The trap is being echoed and then run, so plus trap bang exit. And then you see the CD is being echoed and then run. And here's where our first problem arises, because naturally I didn't even make the directory. Opt-query doesn't even exist. Like I say, this is contrived. But you can see CD is a built-in, and CD failed. And because of set-e, the script stopped right there. It didn't do anything it didn't do anything unexpected, because the precondition, that external precondition that directory exists, wasn't met. So we get the error, cd opt-query, no such file or directory, bang. So our shell function is now running because it's part of the trap for exit. So the shell is now exiting because of the set-e. Bang is being run, it echoes failed, that's what we saw on our terminal, and then it exits 1. So let's make opt-query. Let's truncate that log file, and let's try again. Clearly it's going to fail immediately again. So why did it fail this time? You see the cd opt-query worked this time, right? See it echoed, see the plus. Then we see the lock. I didn't make the lock fail. So it locked. We got the lock on a file. And then it went to source opt.crmlogs.conf. Well, that file didn't exist. And you can see it again is no such file or directory. So Bash actually does a reasonably good job of giving us reasonably understandable error messages. That file doesn't exist, no such file or directory. So clearly that's a reason for this script to fail. An external condition that the config file exists wasn't met. Bang, there's our exit trap running, and it's saying failed to the standard error, and it exits. Okay, so let's put some stuff into opt.crmlogs.conf. I'm just echoing log keep and log pat into there, and then I run rmlogs again. Failed, failed, failed. Well, why is it 3 fails, right? That's weird. All right, so here's where we start to get into some of the little nuances, little things that are non-intuitive about how this stuff works in Bash. So let's go through those. So here we can see in the log file, we're a little farther down. We've sourced rmlogs.conf, that worked. Log keep equals 7 log pat. Now you see 2 pluses here because we're actually a second level deep. Sourcing is another level deep. Let's just leave it at that. And then we do our find, but here we see dblog keep unbound variable. And here we see dblog pat unbound variable. And the reason they're unbound is because I got the names wrong. I did it on purpose, but I got the names wrong, right? The name is debug log keep, and I just wrote log keep. So here's the set-u catching the fact that these values weren't defined. We can see bang is being called in each one of those cases, that one variable is unbound and then the other variable is unbound. But then we see the RM was run anyway, and it had an error because it didn't have any files to remove. We can see its message, missing operand. So that's, you didn't give me a file to remove. And then bang again, and then failed. That's why we saw failed 3 times. But why didn't Bash exit with the first problem? And the reason is it's a pipeline. Okay, so a pipeline, Bash treats a pipeline as special. Parts of pipelines can fail, and it only pays attention to the final piece of the pipe to say that's the part that with the exit value that I'm going to pay attention to. Now it turns out if you're really sensitive to each part of that pipeline, there's actually something called pipe fail, which you can turn on, which will take the rightmost non-zero value as the exit value of the entire pipeline. So at that point, you could be sensitive to failures earlier in the pipeline. But in this case, we don't want that because grep, if grep doesn't find a pattern, it actually gives a non-zero exit value. And it's entirely okay if we don't find any files to throw away. So we don't want Bash to fail on grep not finding something. So we're not using pipe fail in this case. But this is why we have the 3 failed. So what do we do about that? Well, this is actually reasonably easy to handle. So here I went and I put the values, put the variable names the way they should be. And I also added a read-only. That's another nice thing you can do. If you know you're going to set a variable once and never change it after you've set it, you can set that value to read-only, and then if some time later you try to assign to that variable, that's also an error. So we've set those variables read-only, and then I've just diffed this newer version of the file with the last version of the file. So what did I change about this file? Well, I added the -r to xargs, which says don't run the rm if there's no input. So this is going to keep rm from failing if there are no files to remove. But I also added this colon debug log keep debug log pat right after I source the file. What am I saying here? Colon in Bash is a no-op. It does nothing. Except that these calls to these variables are going to be interpreted. So if they are not defined, then our set-u will fire. And it will fire in a safe context before we get to that pipeline. So this is a way you can make your scripts more bulletproof. If you have variables that you're sourcing and using, you can just put them in a no-op context so that Bash will make sure they're actually set before you try and access them in something like a pipeline. All right. Okay, maybe we're doing good on time. I might need to speed up. So I ran the script again here, and this is the first time it actually succeeded. So I finally got all my external dependencies taken care of. What does it look like when it actually runs? We can see the read-only, debug log keep, debug log pat. We can see the no-op, and then we can see the plus line where we've actually interpreted and substituted for those variables. So the 7 and the dump. And then we can see find being run, grep being run, and xargs being run. This is again one of those areas where the set-xv can be a little non-intuitive because the order of these commands from this pipeline isn't set. Sometimes they'll be echoed in a different order, and that's okay because the way pipelines work is all the programs get started and then they output to one another. And so sometimes they will show up in different orders, but they will always be correct in terms of how they function. It's just how it might look in your log file that they might show up out of order. In this case, they actually showed up in order, so that happened. And finally, we get through the successful exit of our script. Trap, dash exit, and exit 0. So we disabled the trap, so bang isn't going to run, and we exit 0. Okay, now let's actually make some files so that we can test this a little bit more realistically. I'm not going to go through this, but I'm just using sequence and touch to make some files, and some of them are older and some of them are newer. Some of them are called dump and some of them are called keep. So here we run the script and we can see removed dump 125, 123, 124. Again, order is not really important here of these files. But I did use the -v argument to rm. And you almost never use -v on rm. It's like one of the most useless arguments to a program ever, except for this context, where you actually do want to know, what did my script do? So here we're using the -v to good effect because we captured in the log file that we removed these files. But you know what? Maybe we want to know a little bit more. Maybe we want even more transparency. Maybe we want to see what files did we consider along with what files did we remove. We can do that by adding a little extra piece to our pipeline. So the extra piece I added to the pipeline here is t-a dev standard error. It's going to take that standard out in that pipeline and duplicate it to the standard error. The standard out of the pipeline is going to the next part of the pipeline. The standard error is connected to our log file. So here we get to see everything that was handed to grep. So we can see that our find saw the keep files, saw the dump files. We can see what was considered, and after seeing what was considered, we can see what was removed. So now we have good transparency to our script, and we can understand very clearly what it did. We can even reason about whether our pattern matched what we wanted it to match. Okay, so that's enough of looking at the script for a while. Let's step back and talk about a little more Bash. Bash has two ways of testing expressions. One is a single pair of square brackets, and the other is, the double square brackets. How are these different? Well, when you use the single square brackets, this is when you're most often going to have problems, because word splitting and path expansion occur to arguments within those single square brackets. Word splitting and path expansion is explicitly avoided when you use double square brackets. Let me give you an example of this. So let's say I set a variable foo, and I set a variable bar, and bar has a space in it. Ooh, that's evil. If I ask, is foo equal to bar using the single square brackets, I get the dreaded bash too many arguments. What's happened is bar was replaced, bar had a space in it, so now our expression looks like 1 equal 1 space 2, and that's not syntactically legal for that expression test. But if I use the double square brackets, okay, what is our usual solution to this? Quote, the usual solution to all word splitting problems is to quote everything. Well, you can actually just use double square brackets, and that's better. If you use the double square brackets, you don't have to remember to quote something. So foo equals bar, and that works even despite the fact that there's a space in there because word splitting did not occur. Here's the example for path expansion. If I use the square brackets and just ask if the single file keep.130 exists, well, yes, it does, and life is good. If I say, does keep.star exist? Well, now I've got too many arguments again, because keep.star was 4 files, and that's not the right syntax for that test. So if I use the double square brackets and ask if keep.130 exists, well, yes, it does, and that works fine. But if I ask keep.star exists in double square brackets, that's not fine, because path name expansion isn't being done here. So little thing to watch out for. If you really do want to ask the question, are there any files that match this glob pattern? You can use something like this final expression, which uses ls combined with grep to ask the question, does this file exist? ls is going to list all the files. Grep is going to look for a pattern. We can fairly trivially map glob expressions to regular expressions, and then we can echo true. So this is a way, and the one additional advantage of this final expression is that this works no matter how many files you have in a directory. Bash has a limit on how many files it's going to use with the glob expansions. And if you go beyond this limit, you'll get unexpected behavior from your script. So if you want it to be bulletproof, try to avoid using globs inside bash expressions and instead use things like ls pipe to grep or use find or many other ways to explore the contents of a directory. Mm-hmm. Oh man, you got to make me go back.
The ls would always turn out false because it's actually not looking in the subdirectory, wouldn't it?
Well, keep.star also isn't looking in a subdirectory, right? So if you want to look in
looking for the files in the directory, not in the keep sub.
Right. But if you want to look in subdirectories, then use find here. So there are definitely ways that are better than globs to handle this and have bulletproof expressions. And usually they involve something like find and not something like square bracket -f keep.star. Okay. Okay, let's talk about internal field separator real quick. Internal field separator is the set of characters that's used for word splitting, and it defaults to space, tab, and new line. Now, if you set the value explicitly to null, then you turn off word splitting. If you unset the value, it's just as if it had the default value. So that's a little something to pay attention to. Also, the first character of IFS is special in the sense that for $, the first character is what's used to separate the values when you're doing that inside of a pair of double quotes. There are some other special cases. You can read the Bash man page for it, but I don't necessarily recommend it. Why am I bringing up IFS? Because you can actually use IFS to get Bash's word splitting to do your bidding. If you want to turn off word splitting for a particular shell function, you can do that, and that can be valuable. So, we've talked about double square brackets is valuable because it doesn't do word splitting. Well, you can say this whole function should not have word splitting, and you can do that by briefly setting IFS to null and then maybe just unsetting it to get back to that default value. Quote, quote would work. I've got an example here where I just don't even put anything after the equal sign, right? So that's effectively setting it to null. So here I'm just showing with hex dump what is the value of IFS. It's space, tab, and new line. And then I set a variable foo to a space b space c, and I'm asking the question. I maybe skipped a slide where I defined what inargs was, but all inargs is a shell function that's saying echo each argument with a number in front of it. So inargs foo is saying that the first argument was A, second argument was B, third argument was C. Then if I set IFS to null and I run that same command, inargs foo, you'll see that what it sees is a single argument of A space B space C. So this is a way you can use IFS to your advantage. Again, unset IFS and then run it again, and you can see it's back to 3 separate arguments. So you can use IFS to split a comma-separated value file. You can use it to split a tab-separated. Well, tab is already in there. Never mind. To split only on tab. You could do that. Okay. Error versus exit traps. If you're looking at the traps part of the bash man page, you're going to see this error trap, and you're going to think, why don't I just use that? That's better, right? What the error trap does is it fires on the same conditions of set-e. But there's a pitfall. It's not inherited by shell functions. You can get around that pitfall by using set-E. But this is about being bulletproof. So if you have to be cognizant of a pitfall and then remember to get around the pitfall, then that's a potential for making a mistake. So I just recommend avoiding error as a trap and instead using the exit trap. Now, another complaint you might have about exit is it's unconditional. But you can make it conditional. When the exit trap runs, the $? is actually going to have the return code of the last thing that ran. And if you're exiting successfully, that return code is going to be 0. If you're exiting unsuccessfully, it's going to be non-zero. So if you, instead of saying bang, if you say something like end, where you capture that value of $? Then you can do some other things, like some cleanup code. And then you can test whether RC was equal to 0. And if it wasn't, then you could say failed. And then you can just exit whatever that RC value was. So this is a slightly more, a slightly friendlier version of bang that only actually says failed when something really did fail. So let's give a final version of this script. This time, the only real differences are, first off, I got rid of base name. Bash actually has built-in ways to trim values to trim pieces of variables. So base name is actually redundant now, because you can just take the value of $0 and trim off everything up to the last slash. So that's what I'm using for the me value here. Instead of bang, I've got end. And end, here what I'm saying is $question is equal to 0, just return. So we don't get the failed language. And now that I've made end be conditional, I don't need to unset it at the end of my script. In fact, I don't even need to exit 0. Because we're using set-E here, the script is going to exit 0 because everything succeeded. Otherwise, it's going to exit with a failure. So the final part of my script is just the find. And this is what I want my bash scripts to look like. The most important thing is what it does at the end. It's pretty plain. There's some boilerplate at the top. flock. I almost forgot to mention this. Maybe you don't want your script to give an error when the lock is already being held. Because, maybe it's okay if the script's taking longer. Maybe you're having cron run your script every 5 minutes, and sometimes it takes longer than 5 minutes to run, and that's okay. Well, because end now looks at the exit code, we can have flock be flock-in4 or exit 0. If I didn't cover that before, flock is using the file handle for as what it's locking on. So immediately above the flock, there's exec for greater than .me.lock. Okay, I think we're, I should mention, there's a program out there called shell check, which is pretty good. If you run shell check on your script, it's going to catch a lot of the problems that would result in non-predictable behavior. But it's also going to lead you down the path of double quoting everything. So it's kind of like an old-fashioned linter in that it's very persnickety and it complains a lot. You know, I don't really want to put double quotes around $me in every part of my script because I don't put spaces in the names of my shell scripts. And if I did, shame on me, and it's going to fail somewhere earlier, and I'm going to see it in the log file and go, you put a space in there. So shell check is pretty good. You can use it online at shellcheck.net, or you can, on most distributions, you can install it. It's a package. It's been around forever. You can install it and use it directly from the command line. So shell check is good. If you take nothing else away from this talk, try using shell check. It might actually help. I have some extras, but I think maybe we're almost out of time, and I wanted to leave some space for questions. So we'll just leave that off, and I'll ask, does anybody have any questions?
So I always use pipe fail
Mm-hmm.
and then a test like when I need to. You don't think that's a good pattern to follow?
Always doing something. You know, it's funny, in this script, I actually went back and changed the backticks to be $open paren and close paren. I always use backticks because I'm old-fashioned, and backticks are how you do that, right? This new $paren business is newfangled. Well, shell check always complains about using backticks in your script. It's like, don't you want to use this other thing? And you can nest it. And I'm like, yes, but I never nest things like that. So it's one of those things, if you have a habit of thinking about pipelines such that you have it ingrained that earlier parts of the pipeline can reasonably give non-zero exit values, like grep. Grep is the great example. Then, again, maybe you don't want to use pipe fail. But if you have it ingrained that you never want anything to give a non-zero value unless you're paying attention, then maybe you use pipe fail. So I guess that's a matter of taste. Any other questions? Do I have any time left? Do we want to talk about these? We mentioned pipe fail. I'll just mention these two briefly. Null glob and fail glob. So globs, again, they're not, if you can avoid them, do, but they're also useful. So here you can actually change the way globs behave. If you set null glob and your glob doesn't match any files, Bash will just pretend you didn't have it there in the first place. So that can be valuable in certain cases. Fail glob is the opposite. You can say, if this doesn't match a file, I want you to stop and treat that as an error. Now, you might be wondering, well, what is the default? Well, the default is, if it doesn't match, then the word with the glob characters is actually handed as an argument to your program, which is almost never what you want. So these are actually reasonably valuable if you're paying attention to that sort of thing. Okay, finally, I like XKCD. Doesn't everybody like XKCD? But I love this line. His blog has 4 posts. All apologies for not posting more. Well, that's my blog's kind of like that. I can relate to that comment, but at least I'm going to put these slides up here at this address, which is my sometimes blog, codeacumen.info, and I should have them up here by the end of the day, I hope. So thank you. Thank you for coming to my talk. Enjoy the rest of yourself. You're LinuxFest. Okay, yes. Let's see. Does it come back? Yes, it comes back. I am one of probably the only person here using Apple products to do their presentation, so, you know, got to be different, right? But in my defense, I know that there's actually a fairly traditional Unix under the hood here, right? It's not Linux, but, you know, it's based on the old Next. So, you know, there was Unix before there was Linux, and, you know, we should keep an open mind. Hey, there was. Yeah, all right. Okay.